Hi, I'm Hein. From this week, I'm gonna talk about some knobs to solve the SE problems. This week, we will talk about the knobs to solve the velocity saturation problem. The velocity saturation is representative problem of SCE. When the channel length becomes more, maybe sub 100 nanometers, the velocity becomes saturated when the electric field becomes strong. Uh, the velocity is equals to the mu times the mobility of the carrier times the electric field. So in ideal situations, the velocity have to increase when the electric field becomes strong. But in short channels, the velocity becomes saturated when the electric field becomes strong. It means the mobility of the carrier become degraded when the electric field becomes strong. The degradation of the mobility, of course, the problems like the current become decrease when in the device. To solve this problem, we will talk about some knobs to solve it. Before we talk about the knobs, we have some mechanism of these problems. We have to solve the degradation of the mobility. How we solve it, how we boost the mobility of it, it's simple. The velocity of the device increase linearly when the electric field becomes strong. And we know the carrier velocity is reversely proportional to the effective mass of the carrier. Then how we make the effective mass decrease of the device? We can find the answer at the EK diagram. As we studied at the Physical Electronics 1, Part 1, we studied the effective mass is reversely proportional to the curvature of the EK diagram. It means to decrease the effective mass, we have to the sharp curvature of the energy diagram in the K space. And when we decrease the effective mass of it, the velocity become increase and it leads to the boost the mobility. So to solve the velocity saturation and mobility degradation problems, we have to control the EK diagram curve by engineering some structure of the device. Today we are talking about some knobs to control it, like the strain engineering. In EK diagram, the kinetic energy have some directions. So the directions exist in the same time. But if we give some stress on the structure, the kinetic energy become splitted with the different energy level. So when we give some stress on it, and the kinetic energy level becomes split, the electrons or holes can move to the lower energy, which have the sharp energy dispersion curve on the EK diagram. By this principle, we can control the concentration of the carriers which have the lower energy, which is the sharp curvature of EK diagram, it means we can control the effectiveness of it. By controlling it, we can change the mobility and change the velocity of the device. To give some stress on the structure of materials, we can use the strain engineering. The principle of it is a little bit simple. We grow some architectural layers on a material which has a different lattice constant. So in the boundary, because it have the different lattice constant, some molecules get some stress like compression or tensile. When we compress or tense the lattice structures, the EK diagram moves, and we can make the different form of the EK diagram, the energy dispersion in EK diagram. We can control it in the view of the fabrication process. We can use two types. The first thing is wafer base, the substrate base, and the second is process base. When we use the substrate base knob, it is a little bit less useful than the process base knobs because we can only choose one strain, the tensor or the compression. And when we use the substrate base engineering, it can make a lot of defects which have mismatch of the lattice, and it can lead to some defects like the constant decrease. And if we use some SY structure to make some stress on it, as we know, it can be lead to the self-heating problems. And anyway, the most important problem is the wafer is very expensive. So nowadays many people use the process-based engineering. It can be made when we add some steps which grow some architectural layers on some materials which have the different lattice constant. Today we talked about the knob to solve the velocity saturation problems, which is the strain engineering. From this week, maybe I will keep introducing some knobs to solve the SE problems. Thank you for listening.